This lesson is 7.5, Properties of Logarithms. We learned a little bit about logarithms in 7.4 as far as rewriting the problem from a logarithm to an exponential and being able to evaluate it or solve it from that. The properties of logarithms help us do a lot more. So let me show you a few properties. The first property we have is if you have the logarithm of two things that are multiplied, so this is m times n, and that's an n, not a w, m times n. All right, the properties of logarithms are going to be backwards from the properties of exponents, so this may look a little bit familiar. If I have log m times n, I can rewrite it as log m plus log n, because when you multiply with exponents, you add the exponents. With logarithms of m divided by n, that's going to become log m minus log n. And that's because when you divide problems with exponents, you subtract the exponents. And this last property is when you have log m to the n power. This power can actually come to the front, and it becomes n times log m. And that's because if you have a power to a power, then you multiply the powers. So the three rules look like this. Now keep in mind that not only do they go from being on this side to this side, they also go back the other way. And we're going to actually look at how to use them both directions. So first of all, let's look at an example of how you might use this. If I have the log square root of 2 plus log square root of 8, since it's addition of logs, I can condense this into log square root of 2 times square root 8. The square root of 2 times the square root of 8 is the square root of 16. So this is log square root of 16, which is, the square root of 16 is 4. So I have simplified my initial problem from being two logarithms into one logarithm that, if I have my calculator, I can actually put this in the calculator and get a value. That's one way you might see this. We're going to do a few examples where we are going to expand. When you expand a logarithm, basically you're trying to spread it out as much as it can be. And I think I miswrote this problem. So let's try, there we go. So for this example, we're going to have log base 3 of x squared. This expansion is going to be fairly simple because the only thing we can do is we can take this power and move it to the front. So I can rewrite it as 2 log base 3 x. And what makes this easier is that if I'm doing this in a calculator for graphing purposes, then the 2 is just multiplied by the logarithm instead of being a power. The next one is log base 7 x squared y. Now I have more than one thing happening here. I have x squared, and it is times y. So the first thing I'm going to do is rewrite this as log base 7 x squared plus log base 7 y. That splits up the multiplication part of my problem. Then when I have an exponent here, it can be moved to the front, so that makes this be log, let's try that again, 2 log base 7 x plus log base 7y. And this is totally expanded out, and there's a use for this, and mostly the use for this involves solving. But this is an expanded form. This is my solution. Let's try another one. If I have log 5 times the cube root of x, I can write this as log 5 plus log cube root of x. Now the cube root of x part, this can be kind of challenging because you have to actually rewrite it. So if you remember from chapter 6, we did some of this. I'm going to rewrite the cube root of x as x to the 1/3 power. And so now that it's a power, I can move it. So I have log 5 plus 1/3 log x. And that is a fully expanded form. We're not solving anything here, we're just expanding them out. All right, let's try one more. This looks different. That's not log. Actually, it is log. It's called a natural logarithm. When you see ln together, it means natural log, but it is still a form of a logarithm. So we're going to have ln, and I'm going to take ln1 minus ln 2x squared, because these are divided, so that becomes subtraction. Then I'm going to take ln1, and I'm going to break up the 2x squared, so I have minus ln2 plus ln x squared. But remember, they were together, so I'm putting parentheses around this. So then I have ln1 minus ln2 minus, because the negative distributes, and then ln x squared has an exponent, so we're going to move that to the front and have 2 ln x. So my solution is ln1 minus ln2 minus 2 ln x. That is my fully expanded logarithm. Alright, what if it's already expanded? What can we do? Well, we can condense it. When you condense it, you're trying to make one single logarithm. So I'm trying to take this big problem and condense it down to one simple logarithm. So I'm going to look and see, first of all, they're all base 3, so log base 3 4 plus log base 3 2 plus log base 3 2. Addition becomes multiplication. So I'm going to have log base 3 4 times 2 times 2. So that's log base 3. 4 times 2 times 2 is 16, and that is a condensed logarithm. So log base 3 4 plus log base 3 2 plus log base 3 2 condensed to become one simple logarithm, log base 3 16. For this next one, we're going to condense it. Again, I've got the ln this time, so it's a natural logarithm. And I'm looking to see, do I have any x coefficients, is what I'm trying to say. Do I have any coefficients? And look, there's a coefficient here. There's not a coefficient here because it's 1, and there's not a coefficient here because it's 1, so we don't need those. But if I have a coefficient, remember we're going to do the opposite of what we did before, so a number from the front now moves back to the power. So this becomes ln x squared minus ln 3 plus ln 6. I like to do more than one step so I don't make any confusing errors. The subtraction becomes division. The addition becomes multiplication. So this becomes ln of x squared divided by 3 times 6. Ln x squared divided by 3 times 6. And I can simplify a little bit here because 3 goes into 6 twice. So I have ln 2x squared. And that's condensed because it's one single logarithm.